we started by, and this is of course 04, 17, 04, 18. We began by graphing the system that was given, which consisted of y equals 2x plus 1, y equals negative x plus 2. Knowing that these graphs or these functions are both in slope-intercept form, we can easily read off the x-intercept, which is 1. I'm sorry, the y-intercept. And remember, the y-intercept is obtained by letting x equal 0. So we have a y-intercept of 1 and a slope of 2. Okay, so well, y-intercept 1 puts us 0, 1, puts us here. Slope of 2 means we've got to go up 2 to go over 1. So we have a rise of 2 and a run of 1. So we get another point on the graph and we sketch our straight line. Okay, and we do the same thing for y equals negative x minus negative x plus 2. If x is 0, y is 2, so 2 is the y-intercept, and the slope is negative 1. So we go to the point 0, 2, our y-intercept, and we go over 1 unit and down 1. So we go over 1 unit, down 1. So here we have a run of 1 and a rise of negative 1. So we get 2 points on the graph. There are other ways to get points on the graph, but that's the quickest way to get the graph. You can sit down and make a table of 10 points if you want, although that's not what I want to see. That's not the method of this course. Okay? Another way to do it would have been to do the two intercepts. Letting x equal 0, we get the y-intercept. If we let y equal 0, in this case we get 2x plus 1. If we solve that for x, we get x equals negative 1/2. So we would get the y-intercept, the x-intercept to go with the y-intercept. Negative 1/2, 0, and 0, 1. Okay, and we get the intercepts of this one. Probably more reliable to use slope and intercept. Okay, so that's how we get the two graphs, and we see the two graphs intersect here. So between x equals 0 and 1, between y equals 1 and 2. So we estimate the coordinates of the point of intersection. Now, if you think about it, because this thing has less slope than this one, they're going to meet closer to y equals 2 to this y-intercept than to this one. Just look at what's steeper than what. And they're also going to meet between, well, I'm not going to go into that. I can see it's between 0 and 1, and it has to be a little bit to the left of the midpoint. And you might reason that out or not. Okay, you don't have to reason that carefully, although it's good if you can, to make an estimate, and the estimate I saw most frequently was 1/2, 3/2, okay? I think it's going to be a little more than 3/2, and I think it's going to be a little less than 1/2. And I can see that. You should probably be able to see that it's going to be a little more than 3/2. Okay, but 1/2, 3/2 is a perfectly good estimate, so we can go with that. Okay, now we use the same techniques to graph y equals 3x plus 2 and y equals 3x minus 4. The y-intercept here is going to be minus 4. The y-intercept here is going to be 2. Now, both of these have slope 3. So we go over 1 unit and up 3. So I could say, well, in a rise of 3, run of 1. So here's 1, here's 3. Over here we do the same thing. We go up 3 and over 1. And we get another point on each graph, and then we sketch our two graphs. Okay, now, we should understand very well by this point, and very well actually from prerequisite courses, that having the same slope, these lines are going to be parallel. And if we graph them carefully, they're going to look that way, but the same slope means they just have to stay parallel. Okay, so same slope implies they're parallel, which implies that if two lines are parallel, either they're the same line, in which case they coincide for all their points, or they never meet. Parallel lines that don't coincide never meet. Okay? Well, the y-intercepts are different so that they don't coincide. Okay? This point on this graph, this point is on this graph, but not this one. This point is on this graph, but not this one. The two graphs don't coincide, so there's no intersection, so that the lines are parallel. And when we try to do the algebraic solution, we're going to find that there's no intersection. It's going to be very clear. Okay, now, these two equations, the third set, are not given in slope-intercept form. Well, we can still deal with them. We can let y equals 0, and we get 2x equals 6. That means x equals 3, so when y equals 0, which occurs on the x-axis, x is 3. And then if x is 0, y equals 6, so when x is 0, that's the y-axis, y is 6. Now, this is the way we learn to do it. You need to remember this. This is something we build on. Everything we do in a math course is likely to be built on later. You can't just learn things short term or fail to learn them really well, because if you don't, you're probably going to need them and you're going to get on a downward spiral. Okay, that's very dangerous. Got to do the work, got to master every concept as best you can so you can use it later. Okay. 2x plus y equals 6. If we let y equal 0, we get x equals 3. If we let x equal 0, we get y equals 6. Same 2 points. So, for this equation, actually I'm not sure what I was doing there. Well, okay. I labeled the 2x plus 3 equals 6, and that was in white. I've circled this one in purple. This is the other equation. Again, this equation, if you let y equals 0, 4x equals 12, so x equals 3. If you let x equals 0, 2y equals 12, so y is 6. We get exactly the same intercepts, so we get exactly the same line. So what we have is straight lines with the same axis intercepts. They coincide. Every point on either graph is a solution to the system of equations, because every point on either graph gives you an x and a y that satisfies this equation. It also satisfies this equation. Okay. Well, we're going to solve these equations. We're going to use a little algebra and we're going to solve the equations.